Okay, so why I am using the word tools here? Okay, mathematical you understand, but why I am using the word tools? Okay, just like there are different tools for doing a particular task. Okay, can you tell me that why we use tools to perform some task? Sometimes we use some tools. For example, uh, a plumber will use a different tool. Okay, an electrician will use different tool. Okay, a construction worker will use different tools. What does the tools do? Okay, yeah, it makes things easy, right? Handy, more in that way. Yes, it makes things easy, and that's exactly what we are going to learn. Okay, so we will be doing mathematical tools that will make physics easy. Okay, and you know as a class, many of you will be there who will be thinking that uh, who may not have solved too many numericals uh, apart in mathematics, not in physics. You may not have solved so many numericals, but you have to change that attitude now. Okay, because the physics that we are going to learn, okay, can be only completely understood by solving numericals, by using the concepts. Okay, and that's what the training is required for competitive examination. Okay, you have to solve numericals, you have to showcase your concept, that you have your understanding, your comprehension, by solving certain problems. Okay, so problem solving should be your uh, basically, if I say, it should be too much integrated in your studies. It's very, very important. Okay, so starting from maybe, let's say today, you should show the intent of solving lot of problem. Okay, from whatever source you can get it, teachers will assist you. Okay, you solve from this material, this is the assignment and all, you get it. Okay, so be ready for that. At least you should solve 30 questions. uh, I'm saying with the time, let's say after 1 week or 1.5 week, you should solve at least 30 questions in physics, 30 questions in chemistry, 30 questions in mathematics, 30 questions or 45 questions in biology. Okay, you should be solving, show that intent. Okay, that's that's the only way to succeed in competitive examination. If you make it a habit now, okay, so you will be at the upper hand. You will be, compared to other people who realize it later. Okay, uh, we are not naturally inclined towards problem solving because of the education that we have got in the past. Okay, so there were a lot of theory and all those things are there. Okay, that was required because at that time your mind was growing. Okay, and you were not supposed to do a lot of problem solving and all. Okay, but now you are entering an age group where you can use all the knowledge that you have assimilated and show your uh, aptitude and show your problem solving skills. Okay, so now we have to gather that knowledge and solve problems. That should be our intent. Okay, let's see. So let's start with mathematical tools. As somebody mentioned, Himanshu, that tools makes task easy. So mathematical tools will make understanding of physics, chemistry, uh, even biology, some parts, very easy. Okay, so you will get like how to think about a particular situation, how to convert that situation into a mathematical equation or a logical sequence, right? Mathematical steps are what? Logical sequence, right? When you solve an equation, there is a logical sequence. You assume something to be x, okay, then you form the equation, then you solve with some logic. Okay, so uh, yes, that's the mathematical logic we are talking about, but physics is far greater than that. Okay, but to understand the great ideas in physics, you need to express them in terms of mathematical equations. Okay, so you think about any great idea ever discovered about science and physics, it will be in the form of a simple equation. Okay, an equation makes it worthwhile, because all simple ideas can be converted into an equation, especially in science. Can you give me some equations which you think is most powerful for all the entire science subject or entire human race? Can you give me one equation which you feel is very important, very powerful? Anybody remember any equation? Okay, you want to say E is equal to mc square, right? Very simple, small equation. Correct. And there are many equations. Now, this is in public domain, right? Everybody might have seen it, some photograph or some article. E is equal to mc square. Yes, it is very powerful equation. Okay, that's the principle of hydrogen bomb, atom bomb, you know, and nuclear power plants, all those things. Okay. Yeah, and there are many other equations. Okay, so as a student of science, you will be knowing many other equations which are more or less uh, or comparable to this equation. Okay, any other equation you remember after this? Like, I'll list it down, some equation for you. You might have seen or already. Yes, F equal to ma, right? Then, if when it comes to Newton's law, this comes to our mind. F equal to ma. Okay, and yeah, so yes, S is equal to ut plus half at square, v equal to u plus at. Yeah, you remember all those equations, okay? But they are in a particular, they explain something. They explain something. They predict something about nature. That's how things work out. Okay. So there are many equations that you are not aware of it. You might have studied, but you are not aware of it, because that time those equations would not have made any meaning to you. Okay, for example, do you know any relation, any equation for electric field and magnetic field, or electromagnetism? Yes, that's Ohm's law, correct. V equal to IR, that is right. But do you remember any equation of electromagnetic field? Okay, so this mathematical tool, what I'm saying is, this mathematical tool will give you a superpower to look into those equations and make meaning out of it. It will all become meaningful to you. Okay, so we will explore those equations in different chapters, but let us begin with the tools that will help you to understand them. Okay, so the basic understanding of physics depends on mathematical formulation. Okay, so let me introduce you to the most intriguing, most fascinating part of mathematics ever used in physics. Okay, that is called calculus. Okay, calculus. And our PU1, PU2 syllabus is totally based on calculus. Okay, so through calculus we understand the physics. Okay, so apart from other things, we'll see. So do you know who made the entire calculus? Okay, so it was not a mathematician. It was not a mathematician. Okay, it was Newton who made calculus. Okay, he made calculus to explain planetary motion. Yeah, correct, Newton. To explain the planetary motion around sun, that these motions are elliptical. There's a path of the planets are elliptical. People thought that it is circular, but he was the one who explained how it is elliptical. It was Galileo that gave him the data and all. Okay, sorry, not Galileo, Kepler. So Kepler gave the data but he was not able to explain because I don't know how to explain it. So he gave them experimental data, and then Newton worked out a way to explain it theoretically. Okay, so entire calculus was discovered, and that changed the way we look at science today. Okay, and that changed the way of everything that we every technology and everything. Calculus is used extensively everywhere. Okay, all right, so let's begin with that. Now, before we do that, so I'll tell you what are the mathematical things that we are going to learn. Okay, so first thing first, we are going to learn in mathematics tool. We'll start with functions. So I'm telling you all this so that you will know where we are, okay, in what direction we are moving. So first thing we'll do is function. Second thing we'll do is uh, different types of function. Okay, means trigonometry, basic trigonometry. Okay, then algebraic function, mostly. Okay, there's only one way to do that. Okay, so I have to, is not able to join, then I have to end this meeting for me. I'll rejoin in a few seconds. Okay, okay, let's go ahead. So trigonometry we'll study, and then we'll see some algebraic function. Mostly we'll talk about okay, quadratic and linear. Okay, all right, but that's what we are going to do. Then next thing what we'll do is, then we'll enter into, I think trigonometry is done, algebra is done. Then we'll do some graphs. Okay, in algebraic function. Okay, so that is included there. Then we'll start calculus. Okay, then we'll be ready to enter into calculus, which will be our bread and butter for understanding physics. Okay, so calculus is of two parts. We'll finish. One is differentiation and one is integration. Then all right, so after that, when calculus is done, basic calculus is done. It's really interesting actually. So when we'll get there, don't worry, we'll get there and we'll understand it quite beautifully. Okay, we'll capture the most essential ideas of calculus. Then there is a topic known as vector. Okay, once the calculus and vector is done, we'll jump into physics. Okay, so in order to jump into the topics of our syllabus in physics, we'll go through all this mathematical tools. So we'll keep these tools with us all the time. Okay, initially we have to learn how to use these tools, then we'll keep these tools, think like that, and then we will jump into the world of physics, and whenever required we'll take out our tool and solve the problem. Okay, so think like that. So let us begin with the idea of function. Okay, what is function? A function is a relation between two or more variables. Okay, or you can say, you know, in a simpler thought, uh, it is a relation between dependent variable, and independent variable. Okay, example, let's talk about area function. Okay, so if you write area is equal to pi r square, for example, area of a circle, you will say, or think like this, that area, A is a variable representing area. Area of a circle is a function of radius. That's where we can use our vocabulary of something being a function. Area of a circle is a function of its radius. Okay. Can you capture this idea? The next time we'll say area is a function of radius, and the value of the function is given by a is equal to pi r square. So this equation tells you the value of the function. So area of a circle is a function of its radius, and the value of the function is given by, or area is given by, pi r square. Okay, the relation is known to you. Okay, similarly, we can say volume of a cylinder is a function of its radius and height. Okay, so you can represent it something like that, that volume is a function of. Now look at the representation. Okay, sometimes what happens, you don't know the relation. Okay, so have a look at it. So we say that it's a function of, okay, here you can write it's a function of radius. It's a symbol. Okay, it's a symbol that we use to denote area is a function of radius. If you know the value, just write the value of the function is pi r square. If you don't know the value, just start with this simple idea. Okay, that area is a function of radius. Okay, f in the argument r, it's a common notation, don't worry about it. Similarly, we can say in this problem, volume of a cylinder is a function of radius and its height. Yeah, volume is dependent, right? Volume is dependent on radius and height, volume of a cylinder. So, and fortunately we know the value of the function, so we can write it as pi r square h. Okay, so sometimes the a particular function is dependent only on one variable. Sometimes the function may be dependent on two variables, and that is okay. It could be two variable, it could be three variable, it could be n variable, doesn't matter. Okay, but the point is, how do we write it? So just focus on this notation. When you don't know the value and you are expressing the idea generally, okay, so you can write f. Okay, so I mean to say either f, this first letter, okay, denotes that it's a function. You can write f, you can write any letter you want. Okay, so but it could be example notation of a function. In general, you can write it as fx, okay, a function of x, or g of x, or h of x, doesn't matter. Okay, what is it, and so on, as long as it is written in this way. So this is called function, and it is said function, it is read like this, function of x. Okay, or you will write f of x, read like this, is called g of x. You are saying the function name is g and it's a function of x. It is h of x. You are saying it's a function, h is a function, name of the function, and it is dependent on x. Okay, something like that. So let us see. Let me write it here for you. What do you pronounce? Okay, what do you pronounce? So when you say fx, it is read as f of x. Okay, that's how it is read. If it is g of x, you can read it as g of x. Okay, so when you are discussing it, let's say I am discussing with you, I'll say, oh, it is a function of x or f of x or g of x, something like that. So you can represent function by any letter, and f is not important. Okay, this f letter is not important. You can also denote a function by any variable, g, h, v, t, whatever it is. Okay, so let me get you comfortable with this notation. Okay. Now, I have given you an example of dependent variable and independent variable. Sometimes it is dependent on only one variable. Sometimes the value of the function is dependent on two variables. Yes, pi is not a variable. We all know that, right? Pi is not a variable. It came in the form of the description of the function. Okay. No, 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 no. It's not like that. Okay. That's a relation of the function. It's a relation of the function. Okay. So let us start with the idea. Suppose I have a function of x. You will understand it now. Just let me go through the entire thing. Just wait for a while. Okay. Okay. So have you understand the notation? Just have a look at it. You can write it as f of x. You can write it as g of x. You can write it as h of x. Whatever you want. Okay. So what is happening is, think of it function like this. A function is like uh, a program. Okay, it's a program where you input something, what you input x, and what you get out of it is f of x. Okay, so something like that. Input is x and output is the value of the function. That's what the function is doing. Okay, to simplify thoughts. Okay, think like that. So there is a relation, where you put the value of x, okay, and what you get as output, okay, is the value of the function at that value of x, something like that. Okay, now let me tell you a general description notation of a function. Okay, suppose I have a variable. Okay, so I'll keep the variable very general. Let's say I have a variable y which depends on x. So I will start with the idea y is equal to fx. Okay, any problem? Suppose I don't know what y is, what x is. I'm just talking in mathematical sense. I just know y is somehow dependent on x. Okay, so I can start my problem with this idea that let's say y is a function of x. So when you write y equal to f of x, basically you are declaring that you believe that y is dependent on x. That's it. Okay, so that's the start. So think about it. All the values of x is possible. Okay, so x is the input, and what you get will obviously you will get y. Okay, in this machine you will get y. When you put the value of x in the function, you will get y's. Okay, this is called, any problem in this thought? It's quite simple now, so don't worry about it. Okay, so all the values of the x that you are input, okay, that you are putting in the input, this is called, I'm using another vocabulary. Okay, another term in your vocabulary I'm going to add. First we added dependent variable and independent variable. Okay, and now we are adding something called this. All the values of possible values of x is called domain of the function. Okay, so think of domain as something which contains all the possible values of x. Okay, it's a package which has all values of x possible. Okay, and because y is dependent on x, No problem, nothing to understand. I'm just increasing the vocabulary right now. It will become clear. Just wait for a while. Okay. All the possible values of X is called domain, and all the possible values of Y, because of whatever value of X you will put. Okay. That is called range of the function. Okay. So this is called domain of function and range of the function. Let me give you an example. I am saying that all the possible values of, all the possible values of the output, will be in a package known as range of the function. Okay, let me give you an example. Okay, okay, so y is equal to fx. I was telling that all, just remember one by one, thought by thought. Okay, that all possible values of x is called domain. So as you say, domain is not just one value of x, it is all possible values of x. Okay, suppose x can take values like 1, 2, 3, 4, 5. Then domain is not 1, domain is not 2, domain is not 3. A domain is a set of values. Okay, so when you say domain, you will say, okay, all the values of x means 1, 2, 3, 4, 5, all. Okay, think like that as a box. Okay, so balls in the box. So individual balls are fine. When you talk about domain, that you say, okay, all the possible balls are in the box. So the box is called domain. Does that make things simple for you to understand? The box is the domain. Okay, there are a lot of balls in the box. The entire box is called domain. Yeah, something like that. Similarly, all possible values of output or y, fx or y, which is dependent on x, is called range. Just for general knowledge, will not be anyway using domain and range in our day-to-day life, but it's just to give you some general knowledge. Okay, so when you talk about function, so a function takes some values dependent upon a choice of an independent variable. The independent variable will be taken from the box known as domain. Okay, then it will be processed according to the function, and the outputs will be put in a box known as range. Is it okay? So think of it like uh, domain as some input values, and range are all possible output values. Okay, now let's get back to the uh, use of this. Suppose it's very simple actually. The introduction was only because it's new, it was supposed to happen like that. Okay, think about it. Suppose I have a function y is equal to fx, and this value is given by x plus 1 by x. Okay, obviously x, uh, okay, let me tell you. Okay, like this. Suppose it's a function, it's an example. Any problem in understanding that? Here you have a value y which depends on x, and how it depends on x is also mentioned, that it is x plus 1 by x. If I ask you what is the value of y, okay, find the value of y, at, let's say, question number 1, at x is equal to 1. Second question, at x is equal to 2. Okay, go ahead, solve. Tell me if that makes sense to you, what is being asked. Okay, so first example, I'll do it in front of you, otherwise again Some people will get confused. If you know, if you understand, go through your logical sequence. For rest of you, I'll do it for you. Okay. Now see, you will say at x is equal to 1, y will be equal to, x, you have to put here the value of x as 1. So you will get your answer. The function is x plus 1 by x. So you just substitute that value. So you'll get 1 plus 1 by 1. Obviously, you will get 2. So the value, the answer for this is y is equal to 2. If x is 1, then y will be 2. Is it difficult? Not at all, right? It's not at all difficult. Okay, so don't worry about it. Have some patience. Just go through it. Okay. So now let's see. At x is equal to 2, the value of y will be given by x plus 1 by x, whatever is the value of x. Now what we'll do is we'll put the value of x equal to 2. So 2 plus 1 by 2. Okay, so obviously 2.5 or 5 by 2, whatever answer you give, it's all correct. Okay. So right now you just evaluated the function at different values of x. Okay. So that's what it is. Nothing, no big deal. Okay. So it's just a function is a beginning of an idea. Okay. You are saying, okay, I have a variable which depends on other variable. Depending upon whatever is the value of the other variable, my dependent variable will have this much value. Okay. Now, can you tell me a value? Just a bonus question. Not, I don't require that in physics. Okay, but just a bonus question for you, just to ignite the thought. Can you tell me which value must not have been in the domain of the function? Domain of the function means all the possible values of x that you can take for this function. Okay. Okay. So what will be the domain of this function? Amazing. Great. So when I say what is the domain of the function, what you will say? Obviously, you will say anything but 0, right? Isn't it? You will say anything but 0. Means every other values are possible except x equal to 0. Negative values you can take, right? For example, let's say third question, find out the value of the function at x is equal to -3. Go on, solve. Okay, third question. So this is the first solution of first question, solution of second question. Now let's get to the third question. You can take negative values, not a big deal. How does that matter? Go ahead, see for yourself. Just put the values. Our function is what? At x is equal to 3, -3. Our function will be -3 plus 1 upon -3. Okay, so I use a lot of brackets when negative values are there to clarify things. Okay, so be a little careful. That's all it needs. So we'll have -3 minus 1 by 3, right? So we'll get -10 by 3. Correct. See, all of you are just got the hang of it. It's not a big deal. Good. Nice to see that. All right. All right. So from this question, did you understand what is domain? Okay. So domain is simply, I don't require that in physics. Okay. But anyway, just for general knowledge. Okay. So domain of this function could be anything except for 0. Okay, because at 0, 1 by x is not defined. Okay, 1 by x will not be defined. That's why. Okay. Out of curiosity, can you tell me what will be the value of the function at x is equal to Let's say x equal to r. Can you make sense of it? Yeah, correct. Good. That's right. So naturally you are getting in the idea that it's fine, whatever it is, as with any other values, if x is equal to r, I'll simply write y will be equal to r plus 1 by r. How does that matter? It's a natural thought, right? Okay. I know. So thumbs up. Let's see. One more question for you. Fifth question. That what will be the value of y at x is equal to f of, let's say, f of 1. What could be the meaning of this? Now this could be a little confusing, but some of you will definitely get it. Let's see. At x is equal to f of 1. Okay. So I'll just give you a better view of what I mean by f of 1. Okay. See, now this is a notation. Okay. You have to understand the meaning of this notation. That's it. It's a code word. Okay. But pretty easy, not difficult. So first we'll see what is f of 1. Okay. So you see, this is what f of 1 is. Okay. F of 1, what is the function? F of x is x plus 1 by x, right? Whatever. Okay. Then what will be the meaning of f of 1? First we have to find out. So think here that f of 1 would mean 1 plus 1 by 1. Is it okay? And that's 2, right? What we want? We want the value of y at x is equal to f of 1. So what we'll do is we'll substitute this value here. So that's 2, right? So actually what question says is find the value of y at x is equal to, y at x is equal to f of 1, means at x equal to 2. Then what is the function? Function is, think of like this, f of 1 plus 1 by f of 1. You can write like this or directly use the value 2, no problem. Okay. So now we have understood what at what x they want the value, and that is actually 2. So we'll write, okay, what is the function? X plus 1 by x. So 2 plus 1 by 2. And we already know what is this, okay? And that is 2 point, how much this was? 2.5, right? Okay, so I'll give you some time to think about it. Let me know if you have any difficulty in understanding the logic. Is it fine? Anybody has any issue? Any doubts? Okay, good. You know what this is, what is this called? This can also be denoted like this. Think about it. Fifth, I could have given you a question like this. What is f of 1? Okay, just for fun. Okay, I don't require this in physics. Just for fun. F of 1. What that would mean? See, the function that we know is yeah, here it is. F of x is x plus x, है ना? So given f of x is x plus 1 by x, then the meaning of f of 1 would be what? Okay, it would be meaning that what is f of 1? We know that f of 1 is 2, right? F of 1 is 2. Then actually its meaning is finding f of 2. And we know f of 2 also, right? F of 2 we have calculated. So at 2 the value is 2.5. That's another way of solving the problem or the notation. Just getting you comfortable with these notation, it's not a big deal. Might be a little confusing at first, but not difficult. Okay, then let's move to another example. Okay, this time rest of you should answer. Okay, I have a function f of x, or let's say I do f of theta. Doesn't matter what is the notation of the variable. Okay, and let's say f of theta is sine theta. Okay, plus, let's say, plus 3. Let's say I have a function which depends on theta and its value is sine theta plus 3. Okay, can you tell me the value? Find question number 1, f of 0. I'll use the same f of 0. Find f of 90 degree, something like that. Just 2 questions, no big deal. This time the function is a variable of angle. Okay, Himanshu, are you able to understand? You have any doubts about this? Okay, so I think everybody is comfortable with this, right? So we'll get f of 0 means sine 0 plus 3. Now those of you who don't remember sine of 0 degree, obviously you have to check on this. Okay, so you have to know the basic sine cos tan of 0 degree, 30 degree, 60 degree, 90 degree. That we will study in trigonometry again. But I am here I am believing that you might be knowing sine of 0 degree. Sine of 0 degree is 0. That's why people are giving the answer as 3. And sine of 90 degree, then you will write sine of 90 degree plus 3, as the function says. Sine of 90 degree is 1. Okay, and then hence it will become 4. So that's how the answers are coming. See, it is pretty easy. Okay, so let me, because it's new, so I'll revise it a little. A function is a relation between independent variable and dependent variable. Okay, so any relation that you see is actually a function. A function is represented by f of x or g of x or h of x, whatever it is. That letter f is not that important. Okay, that syntax is important. Okay, that syntax is important. That notation is important. The function could be named f, or it can be named g, or it can be named any other letter. It doesn't matter. Although we usually write f, that's okay. Here also we have written f. It's okay. All right, so all the possible values of x that you can input in a function is called domain, and all the possible outputs, that set is called range. Fine, I don't need domain and range in my discussions, but I just pass on that information to you. It's important. It will help you to think in some cases. Then you can see that I just have to, finding the value of the function at a certain value of the independent variable. It's so easy if you know the function, what it is. Okay. So we have just discovered what is the meaning of different mathematical expression here. Okay. Some of you were asking doubts about this one. So I'll repeat once again for you. Okay. So like this one. So f of 1, okay, it means. So in here, it means that, okay, so I'll repeat it again. F of 1 means that at what variable? So first you evaluate this term, okay? First you evaluate this term. What is f of 1? Then we'll see later. So this is equal to f of 1. F of 1 we have calculated, you see. F of 1 we have calculated somewhere. I think at the top we have calculated. Means the value of the function at 1, which is also at the top. So I'll just show you that. See, f of 1 we have calculated and its value of is 2. So that means we have to find the value of the function at 2. And the value of the function at 2 is also calculated actually. The value of the function at x equal to 2 is 2.5. Or you can use this function where it is, yeah, this one, 2 plus 1 by 2. And that's why the answer will be 5 by 2 or 2.5. Is it clear, Himanshu? Okay. Don't worry about the notation. Okay. Just for fun, we have done that. But it is used in function. Okay. So when we are learning function, it's better that we are aware of all these variations. Okay. So let me walk you through. Okay. So one quick question again, one example. This time I have a function. Let's see how many of you can do it. Okay, just a challenge problem. The solving of this problem doesn't influence your learning in physics, but yes, certainly some, just checking your mathematical aptitude a little. Okay. Yeah, so here is a function. A function is defined by fx is equal to x square plus 3. You have to find f of 0. You have to find capital f of 1. Okay, that second one is f of 1. Okay, f of 0 and f of 1. And f of x square, f of x plus 1, and f of 1 separately. Okay, so first you will do f of 0, then you will do f of 1, then you will do f of x square, then you will do f of x plus 1, and then you will do f of 1. Try with this function. So first we'll solve question number 1. What is the answer of question number 1? Okay, question number 1. I hope everybody has done that. Okay, so the solution would be like this. This is the function's value, right? F of x means x square plus 3 for this. So what we'll do is in place of x we'll put 0. So 0 square plus 3. So answer is 3. Next question is f of 1. So you will have 1 square plus 3. Answer is 4. Correct. Next question please. Good, good. Next question answer please. F of x square. Okay, correct. Correct, correct. Some of you have got the answer. That instead of x we'll put x square. Okay, so it is x square plus 3. Just have a look at it and tell me if you are getting it. Okay. means whatever is x, the x is, this part is x, so that should be put here, and then square of that plus 3. Okay, that's what it is, right? Whatever is x, you are squaring it plus 3. Okay, next question is question number 4. So net answer will be x to the power 4 plus 3. Okay, x to the power 4 plus 3. Next one is yeah, so here we will put x plus 1. Instead of x, we'll put x plus 1. Square of that plus 3. Just see the syntax. Same logic. If you want to expand, you can expand. It will become x square plus 2x plus 1 and then plus 3. So it will be plus 4. So x square plus 2x plus 4. Take your time. We are not in a hurry. Just make sure that you are understanding each and every step. Fifth question is f of 1. So first what we have to do is what is f of 1, okay? F of 1 we have already calculated. See, f of 1 is 4. So this question means f of 4. And f of 4 can be calculated by 4 square plus 3. Correct? F of 1 it is, right? F of 1 is 4. What is 4 square plus 3? So 19, right? That's it. See, that's what you need to learn about the function. I can work with this much knowledge, okay? The detail about functions will be explained to you, okay, in class 12th when you start in PUC2. If you're taking mathematics, you will learn about function in much more detail, like finding range, finding domain. I don't need that here, okay? I just want you to have a basic idea about function. If you are comfortable with this much content, I'm fine, okay? We can work with this. Okay, so that will be all from today. Okay, then we'll start with trigonometry. Okay, that will start. Function is done today. We'll start with trigonometry. Okay, in the next lecture. All right, thank you so much. One attendance you have to do. Okay, wait. One attendance you have to do. I'll give you the link. What you have to do is write your first name and last name like you did in the last class, previous class you have done. So accordingly you have to do. I'll just share the link with you.